This is problem 127 from chapter 10. It's a limiting reactant problem again. That is almost told to you this time because it says one of the reagents is completely consumed. So we've got to figure out the limiting reactant. Again, convert to moles. Take a look at the mole ratio. Well, this time it's 1 mole of iodine to 5 moles of fluorine gas. And we find that after comparing the moles with that mole ratio, we find out that iodine is the limiting reactant, and that we only need 0.197 moles of fluorine, and we have 0.263. Those numbers are important later on when we get to part B, so keep that in mind. Now we can address part A of the problem. We're looking for the partial pressure of IF5 gas. We need to use the balanced equation to find the number of moles of IF5 that are produced. Again, the limiting reactant controls this, so we've got a 2-to-1 ratio. So we're going to make 7.88 times 10 to the minus 2 moles of IF5. We have moles, we have volume, we have temperature converted to Kelvin, and it's just a simple plug it into the ideal gas equation and solve for the partial pressure of I5, and you should get 0.515 atm. So now in part B of this problem, we're looking for the mole fraction of IF5. And so back in the beginning, when we figured out what the limiting reactant was, we also needed to realize or be able to calculate the amount of F2 that's left over. And so that incorporates that 5-to-1 mole ratio, subtracting the number of moles of F2 used from the amount that we have, because we need to get the total number of moles left in the container after the reaction stops. So the mole fraction is going to be moles of IF5 divided by the total moles in the container. And so we end up with 0.066 moles of fluorine and 7.88 times 10 to the minus 2 moles of IF5. That's the total. And we end up with a mole fraction of 0.543. And so now if you need to figure out or see how we got the 0.066 moles of F2, that again is starting, we know we started with 0.263 moles of F2, and we consumed 5 times the limiting reactant quantity. So we subtract those two from each other, and we end up with 0.066 moles of F2.